Alright, we're in the 5th video in Chapter 6, the nomenclature or the naming system of inorganic compounds. What we're going to look at in this video is we're going to start off looking at polyatomic ions, and from there we're going to use polyatomic ions to name ionic compounds containing them. So let's talk about what a polyatomic ion is first. Poly means multiple, atomic, so ions that contain multiple atoms that are covalently bonded together. So here are some examples, just so you know exactly what I'm talking about here. There are many different types of polyatomic ions. These are some of the more popular ones. I'm going to give you a list on the website or in class where there are certain polyatomic ions I definitely want you to know the names of. So let's look at a few. Here we have C2H3O2 negative. H3O2 negative. Notice it's ionic and it contains multiple nonmetals bonded together. It's a polyatomic anion. The name of this ion is acetate, so it has a specific name. A lot of these polyatomic ions will have specific names that you'll need to learn. Look below it, CrO4 2 negative. CrO4 2 negative. Notice once again it's an ion, it has a charge. The name of this polyatomic ion is chromate. It has a close cousin, Cr2O7 2 negative. That ionic compound is called dichromate. Dichromate. There's two chromiums there. There are many more. Permanganate is MnO4 negative, Mn manganese, O4 4 oxygens, and a negative 1 charge. So that's permanganate. There's also hydrogen carbonate, HCO3 negative, and over here on the other side, while I'm erasing, we have carbonate, CO3 2 negative. This is just a few examples. Like I said, this is not a complete list. The list I want you to memorize, once again, is on the web in the module. There's a list of ones that you need to know, and I'll also pass it out during lab when we do the nomenclature lab. So let's talk about a specific class of polyatomic ions called Oxy Anions. Notice it's got the oxy prefix here. These are all polyatomic ions that are anions that contain oxygen atoms. You will know an oxy anion by its name because usually it will end in the suffix ate or ite. If we look back up at the examples again, here we have acetate, and it contains oxygens. Chromate contains oxygens. Dichromate oxygens, permanganate, all of these are oxy anions actually, on top of being polyatomics. The oxy anions are usually one atom that's bonded to one type of heteroatom bonded to oxygen. So like maybe nitrogen with oxygens, or sulfur with oxygens, or chlorine with oxygens. Sometimes you can form a different amount of bonds to a different amount of oxygens as a heteroatom. So some of the oxy anions have more than one structure and name. So that's what we're going to look at. When you learn the oxy anions, there are several of them. There's a few things that I want you to do. In order to learn them all, or the ones that you're going to have to learn on your list, I want you to learn all of the oxy anions in each group that end with the suffix ate first. They're going to end with ATE, chlorate, phosphate, nitrate, sulfate, carbonate. There will be an ate suffix in all the different groups of the oxy anions. I want you to learn those formulas first. For example, nitrate is NO3 negative 1. I will want you to know nitrate. Sulfate is SO4 2 negative. I will want you to know the formula for sulfate. Phosphate is PO3 3 negative, or I'm sorry, PO4 3 negative. Made a mistake there. PO4 3 negative. So what I want you to do is I want you to learn out of the series of the groups of the Oxy Anions, all of the 8s, and I'm going to show you that in a second. I'm going to show you how to learn them in a quick, kind of silly way. You can just memorize them if you want to. Once you learn the suffix 8 ions, you're going to notice in many of those groups there are similar sounding Oxy Anion names, but instead of ending with 8, they're going to end with the suffix "ite." Whenever you see the suffix "ite" instead of an 8, it implies that that series has one less oxygen bonded to the heteroatom, and it's going to have the same charge. So for example, remember how I said this PO4 3 negative is phosphate? If there's a phosphite, and there is, it contains one less oxygen than the 8. So phosphite is PO3 3 negative. Can you guess what sulfite is? If sulfate is SO4 2 negative, sulfate is SO3 2 negative. Additionally, if nitrate is NO3 negative 1, then nitrite is NO2 negative 1. Alright, so does every series have an 8 and ite? Not all the time. For instance, carbonate only has carbonate. There's no carbonite, or one less oxygen than carbonate. So usually in the Oxy Anion series there's always an 8, and sometimes there's an ite. If there is, it's one less oxygen than the 8. Sometimes there's more than just the 8 and the ite in the series, meaning there's more than 2 ways to bond a certain number of oxygens. So if you have a different number of oxygens, maybe that's one more or one less, we have to think of additional ways to name those. For example, if you have one more oxygen in your Oxy Anion, one more oxygen than the 8, then you're going to add the prefix per to the front of that name. For example, bromate is BrO3 negative 1. Bromite is BrO2 negative 1. There's another element in the series, or Oxy Anion, BrO4 negative 1. Notice that the 8 is BrO3 negative 1, bromate. Notice that the other anion, the third we've just shown, has one more oxygen than the 8. We're going to put the prefix per in front of this name, and we will come up with the name of the compound. So instead of just being bromate, it's going to be perbromate. Perbromate. It implies one more oxygen than the 8. What if you have less oxygens? So notice now we had bromite was BrO2 negative 1. That's one less than the 8. What if you have one less oxygen than the ite? So instead of BrO2 negative, what if we have BrO negative 1? In this series, there's a compound that exists. Instead of just calling this one less than the ite, we're going to use another prefix, and it's not hyper. The prefix is hypo. We're going to use, that means one less. So hypo is less, so we're going to have one less oxygen than the ite. If this was bromite, this compound will be hypobromite. One less than the ite, hypo. One more than the 8, per. Alright, does every series have more Oxy Anions so that you have a per and a hypo of the 8 and the ite? The answer is no. Every series has a different number of Oxy Anions that typically exists. So we're just going to learn the ones that do exist. Alright, so you probably do have the list that I'm going to give you. If you don't yet, you can find it on the website. But there's a trick to learning the 8 series of what the formula for the different 8 ions are. From there you can learn the ites and the pers and the hypoites and the perates in each of the polyatomic series. But the trick for learning at least the 8 part of the series, 8, is to learn a silly phrase and learn how to apply the phrase to quickly come up with the structures when you're first learning. If you practice enough, you'll memorize the 8s with no problem, and what their formulas are, you won't actually need to use the phrase anymore. But I find when people first start out, sometimes the phrase helps. So the trick phrase is, Nick the camel ate, so we have our 8 series there, a clam for supper in Phoenix. Nick the camel ate a clam for supper in Phoenix. This is the 8 series, so we'll tell you that each one of these keywords, Nick, camel, clam, supper, Phoenix, will tell you the heteroatom that's used in the Oxy Anion, besides oxygen. It'll also tell you how many oxygens each of the heteroatoms is bonded to in the 8 series, and the charge of that 8 anion. So we'll start with Nick as an example. So here we have Nick. Nick is the key word for nitrate. So notice Nick starts with N. Nick for nitrate. So we know the name nitrate. What is the formula? Well, the formula is going to have the N for nitrogen, and we're going to be bonded to a certain number of oxygens. The number of oxygens in nitrate will equal the number of consonants in the word, the key word. So in the word Nick for nitrate, there's the N, the C, and the K. There's 3 consonants, so we have 3 oxygens. The negative charge, because they're all Oxy Anions, will be the number of vowels in the name. So Nick has 1 vowel in the word, so it has a -1 charge. Nitrate is NO3, -1. All right, let's try a different one. Nick the camel. Camel is going to be the key word for carbonate. So camel will be carbonate. Notice these are the 8s. All right. So the first letter here tells us the heteroatom on the Oxy Anion. The number of consonants in the key word, so here we've got a C, an M, and an L, is the number of oxygens in the anion. And the number of vowels in the word is the negative charge. So carbonate is CO3 -2. So Nick the camel ate, what did he eat? He ate a clam. Clam is the key word for the chlorate series. So the chlorate anion, Cl, we've got chlorine bonded to some oxygens. So the word clam is going to be our key word here. How many consonants do we have? We have chlorine, or Cl and M. So Cl and M, we have 3 consonants in that word, and we have 1 vowel, so a -1 charge. Chlorate is ClO3 -1. So the phrase is Nick the camel ate a clam for supper. So supper is the next keyword. Supper is our keyword for sulfate. Sulfate for supper. So remember, the first letter is the heteroatom. The number of oxygens in the 8 anion is the number of consonants. We've got S, 2 P's, and an R. So we have 4 oxygens because we have 4 consonants in that word. And the number of vowels, we have the U and the E, so we have 2 vowels. Sulfate has a -2 charge. Sulfate is SO4 2-. All right, what's the other one? Nick the camel ate a clam for supper in Phoenix. I don't know how to spell this one. All right, so he ate a clam for supper in Phoenix. Phoenix is going to be our phosphate series, our phosphate anion. So phosphate is a phosphorus oxy anion. How many oxygens? It's the number of consonants in the word. So Phoenix has 1, 2, 3, 4 consonants. So PO4. The charge is the number of vowels. 1, 2, 3. 3-. Phosphate is PO4, 3-. All right. Now, from there, if you know all the 8s, you can learn the ites. So if I ask you what phosphite is, you know that ite is 1 less oxygen than the 8. So phosphite will be PO3, 3 negative. Okay? Hypophosphite would be PO2, 3 negative. You see? All right. So let's practice a little bit here. Actually, you're going to get plenty of practice in class. So let's go ahead now that we know the anions, and let's look at how we name ionic compounds that contain polyatomic ions. And before actually we do that, before we get some practice, I want to mention a few other polyatomic anions that I need you to know that are on the list, but they are not oxy anions necessarily. Some heteroatom bonded to oxygens. So the first one is hydroxide. Hydroxide is OH -1. So it's an oxygen, 1 hydrogen with a -1 charge. This is going to be very important when we get to acid-base chemistry. And in fact, if you study biology, you probably already know hydroxide because you probably use it frequently. We're also going to need to know cyanide. Cyanide is carbon, nitrogen with a -1 charge. Cyanide. So Cn -1. And finally we have peroxide. What does per mean? 1 more oxygen. So if oxygen is O2 negative, that's oxide. Peroxide is 2 oxygens bonded together with a -2 charge. Alright, peroxide. So I want you to know those. Those are some other anions that will come up very frequently. There's one cation that I really want you to know. It's the polyatomic ion that's positive. It's the ammonium ion. Ammonium. So not ammonia, it's the ammonium cation. And its formula is NH4 +1. Alright, these are all found on that sheet I gave you. So make sure you're looking through that sheet. It's online. I'll give you one in lecture, or in lab, when we practice nomenclature in the lab. And hold on to that because those are the ones you're responsible for on the exam.